So in the last video, we had a computer algorithm determining the optimal locations for an antenna array to be put on one sheet of plywood. And in this video, we're going to take those antenna locations and mount them on a real sheet of plywood with some extra bits around it to turn it into a reality, and then install it outside. So the outline for the bits is the following. We've got antenna at the top, and they're going to sit on a top sheet of plywood. The top sheet of plywood will have holes drilled in it at the locations determined by the computer algorithm. And then we've got a bottom sheet of plywood as well here, and this is just for cable routing. So we'll have cables running internally between the two sheets of plywood so that it'll be more sort of weatherproof and animal proof, and there's going to be bracing sitting in between them to keep them apart. In terms of the goals or the principles for this project, we're trying to use low-cost equipment that you would have lying around. So household tools, cheap, easily accessible equipment, and it's easy to build. So this project only took 2 working days working part-time on it. And the idea being that radio astronomy doesn't have to be hard.
Here we have all of the necessary parts to assemble a single sheet TART antenna array. We will need a portable electric drill, some timber screws here. These will be used to attach the sheet of plywood to this battening material. We also need a straight edge, a tape measure, and a 12mm bit. So now what we've done is we've screwed the 2 sheets together and drawn an axis. The x-axis runs longitudinally and the y-axis up there runs vertically. And here is the origin right in the center of the board, and that is where we're going to base all our measurements from. Now we're going to print out each of the antenna positions. Here they are, and we're going to number each one. So the first antenna is going to be antenna 0, then 1, then 2, 3, 4, and so forth. Okay, now all holes have been marked. I'm about to drill each of the holes. This needs to be done with a reasonable amount of accuracy, probably within plus or minus a millimeter. So here is hole number 1. That one was slightly off. That's not the end of the world. It's only off by a millimeter or so. That tolerance is acceptable. So here we have used a 30mm hole saw to cut the holes in the back sheet. These holes will be useful for tightening up the antenna screws. Okay, so here we have the plywood sheet with the holes drilled in it, with bracing placed on the back. This bracing is going to be used to hold the 2 sheets of plywood at a constant distance apart, and will allow us to route the cabling inside the 2 sheets of plywood to keep it nice and neat. Okay, I have turned this over. I am screwing the battens on just to hold them there while the glue dries, and I've brought it inside to help the glue dry because it's a bit cold outside. So here we have the internal structure showing the spaces to keep the gap constant, which makes it much more rigid. And there we have the bottom sheet, which has the 4 access holes for each quadrant. So the wiring, for example, for this antenna here will run to a hole about there. Similarly, for this antenna here, it'll all run to the appropriate hole in the quadrants over here, these holes. So now we're pretty much ready to put the antennas on and to paint it. I think we'll paint it first, which means we'll paint the two pieces of wood separately before we glue them. Now, we've put the array together, both skins, top and bottom. As you can see, we've got one antenna connected here, and under there shows how the antenna is attached. As you can see, I haven't painted the bottom yet, but I will do that. At the moment, this is an undercoat or a primer coat, and at some point I'm going to use some gloss enamel, this stuff here, to give it a tough exterior coat, which should make it last a lot longer. As it stands, this array should last several months without being painted, but paint should mean that it lasts many years. Here is the array with the antennas being added. So as you can see, each antenna feeds through and currently comes out the back. What will happen with this cable is it will be fed internally to come out of one of these holes from each quadrant, which will keep the cables nice and neat and out of the way of rodents and so forth. This device here is a small 3D printed spanner which is used to attach the nut onto the back of an antenna. So you can see this antenna does not have a nut yet. So what we do is we place the nut in the end of this box spanner, and then we feed the cable through this box spanner like this. And then this goes into the back there and screws onto the antenna. Here is the completed back of the antenna array. You can see each quadrant has 6 antennas coming out of it, out of these holes, and these will plug into the electronics. And after that, all that's left is to mount the array. At the moment the array is upside down. I'll just flip it over so we can see the other side. And here is the completed single sheet antenna array. You can see the y-axis is going to point north, the x-axis is going to point east, and this simple sheet of plywood will hold all the antennas in the correct relative position for us to do imaging on the TART.
To install the single sheet antenna array, you can use 3 or 4 wooden posts. I used 3 here, and you install it making sure that it's level and with Y facing north in your desired location. Now that the single sheet antenna array is installed on site, the next steps, which we'll publish in subsequent videos, are to do with installing the electronics, so getting the electronic equipment ready and installed on site, listening to those antenna, and then after that it's the software to produce images of the sky.